Imagine asking an AI for some medical advice and getting a totally made-up answer. It's a pretty terrifying thought, isn't it? Well, today we're going to dive into a project that tries to solve that exact problem. It's all about building a specialized AI medical assistant that's designed right from the very beginning to be trustworthy. And that really brings us to the big fundamental question, right? Can you, or maybe should you, trust an AI with your health? Honestly, it's one of the biggest challenges facing artificial intelligence today, and the stakes, they couldn't be higher.
Because you see, when we talk about AI in medicine, we're really talking about a double-edged sword. On one hand, there's just this incredible promise for what it could do. But on the other, there's some very, very real peril. Let's break down what that actually means.
So here's the fundamental problem with most of the big AI models you've probably played with. Their knowledge is basically frozen in time, based on whenever they were last trained. But honestly, what's even worse is they have this tendency to hallucinate, which is really just a polite way of saying they make stuff up. Now, in a casual chat, that's just kind of weird. In a medical context, it's downright dangerous. This really gets to the heart of the two different ways of doing things. Over on the left, you've got your standard AI. It learns from the chaotic Wild West of the internet. It can be out of date, it can be biased, or it can be just plain wrong. But the goal of this project, what you see on the right, is completely different. It's an AI that is forced to base its answers only on a single, verified expert source. The whole focus shifts from just knowing a lot to being accurate and safe. Okay, so how do you actually get that level of reliability? Well, the solution is both elegant and really powerful, and the best way to think about it is like an open book exam. Let's see how that works. So instead of letting the AI just guess from its own massive memory, we give it one single textbook to use, the Gale Encyclopedia of Medicine. This is a respected reference book written by actual medical professionals. This is its only source of truth, period. And this is where that whole open book idea really comes to life. So a user asks a question, but instead of the AI just trying to answer it from memory, the system first acts like a super fast librarian. It searches the entire encyclopedia for the most relevant pages. Then, it hands those specific passages to the AI and gives it one simple, crucial instruction. Answer the user's question, but you could only use the text I just gave you. And what's the result? An answer that's directly grounded in the source text, no guesswork allowed. Okay, so that's the concept. But how do you actually build a system like this? Well, it all starts with creating the knowledge engine, which is basically just preparing that encyclopedia so the AI can actually use it. First, the entire encyclopedia has to be translated into a language that the computer can understand. And this is done with a really fascinating process called vector embeddings. Think of it like giving every single idea in the book a unique coordinate on a giant map. Similar ideas get placed close together. So this way, the computer can search for concepts and meanings, not just for keywords. To pull this off, the project uses a powerful model from a platform called Hugging Face. And where does this giant map of ideas live? Well, it gets stored in a super high-speed database called FAISS. If vector embeddings create the map, you can think of FAISS as the GPS that lets the system navigate that map almost instantly. So when you ask a question, FAISS can pinpoint the exact location of the most relevant information in just a fraction of a second. So we have our index knowledge base all set up. Now, how do we connect that to an AI to build a chatbot that can actually respond in real time? That's where the answer pipeline comes in. Putting it all together takes a few key tools. Langchain acts like the project manager or maybe the conductor of an orchestra, guiding the whole workflow from your question to the final answer. For the actual brain of the operation, the AI itself, the project uses the Groq API. And the big reason for choosing this one is speed. It processes information incredibly fast, so the chat doesn't feel laggy at all. And finally, a web framework called Flask serves up the whole application, making it accessible to users online. But, writing the code is really only half the battle. You've got to package it all up and get it running securely and reliably on the internet. Let's take a look at that journey from a file of code to a live app in the cloud. This is pretty much how modern software gets launched safely these days. First, the whole application gets packaged into something called a Docker container. The best way to think of it is like a self-contained shipping container that has the app and everything it needs to run inside. It ensures it works the same way everywhere. But before it ships, that container gets scanned for any security holes using a tool called Aqua Trivy. Once it gets the all clear, it's deployed using AWS App Runner, which is a service that handles all the complicated server stuff automatically. It's a pipeline built for consistency, security, and reliability. And you know the best part? That entire journey, from code to deployment, is automated. A tool called Jenkins acts as the foreman overseeing the whole process. And that means any future updates or bug fixes can be rolled out smoothly and efficiently, without a human having to do it all by hand.
Now, we have to talk about something that is incredibly important. We need to be crystal clear about the limitations of this tool and what it is not meant to be.
A huge part of building trust is being transparent. Every single answer the AI gives is generated directly from the encyclopedia, and the system even shows you exactly which part of the text it used. This lets you, the user, go and check the information for yourself. It's not some mysterious black box.
And this is the most critical disclaimer. It has to be said, and it absolutely has to be understood. This tool is for informational purposes only. It is not a substitute for a real doctor. For any personal health concerns, you have to consult a professional healthcare provider.
So this entire project really offers a compelling blueprint for how to create more reliable, specialized AI. It's a major shift in thinking, prioritizing accuracy over just having a ton of knowledge and putting safety way ahead of speculation. And that leaves us with a pretty fascinating final question. If this open book approach is the key to trustworthy AI in medicine, what other high-stakes fields, like law or finance or engineering, desperately need it next?